Right. Hello. This one is lesson 10 for the higher, and it's perimeters and areas of various shapes. Yeah. So we'll start off with looking at perimeters. See if I can get some shapes down. Oh, come on, come on. Right. So a square. A square has all the sides the same. So if this is 5 centimeters, everything else will be 5. So when we're working out the perimeter, which is all the way around a shape, just add the 4 fives. So 5 plus 5 plus 5 plus 5 is 20 centimeters, and it's a linear. Now, the same can be said, or almost the same can be said, for a rectangle. So if this was 10 and this was 5, now, the properties of this are that opposite sides are exactly the same. Therefore, this would be 5, this would be 10, making a total of 30 centimeters all the way around. Now, triangles is the next one for perimeters. Now, there are a few different sorts of triangles, and I'll soon do one that way. There. This is an equilateral triangle, right? And that means that all three sides are the same, and they're identified by these little lines there. So if this was 10 centimeters along the bottom, this will also be 10, and this will also be 10, making 30 centimeters all the way around. Next one is going to be this shape, and this is an isosceles triangle. And an isosceles triangle has just two sides the same. Now, to identify what's going on with this isosceles triangle, we need to have at least some information. Say that's 8 centimeters all the way across, and that might be 20. Without that information, we can't find the perimeter. Now, the left and the right are exactly the same, so that will be 20, and so that will be 48 centimeters all the way around. Now, if you have this sort of thing, and you have what's called a line of symmetry, which is a dashed line that goes right the way through the middle of the shape. So you have we'll look at symmetry much more in detail later on, and this means the left hand side of the shape is exactly a mirror image of the right hand side of the shape. So with a line of symmetry, you might just be given that that is 3 centimeters, just that little bit on the side. Therefore, the line of symmetry tells you that this bit over here is also 3. The isosceles triangle tells you that that is 20, so you've got 46 centimeters altogether. That's it. Now, you can have this shape where that is parallel to that, and the little arrows tell you that, and this is parallel to that one. And this top and bottom are also the same length, and the left and right are also the same length, and this is called a parallelogram. Parallelogram. I don't know where the M is there. Oh, there it is. A parallelogram. Now, you must at least know that and know that. Otherwise, you can't find. You can't find. So this one's going to be 20. This one's going to be 10. So 40, 50, 60 centimeters would be all the way around there. Right. The next bit is we'll look at area. Now, area, if I can come up with a square, an area of a square. Now, the area is this bit here in the middle. And instead of adding to go all the way around the outside, we're going to multiply. So if this is 8 and this is 8 centimeters, 8 times 8 equals 64, and this time the unit of area is centimeters square. And the same goes if we have, if we have a rectangle like this, whereas this is 20 and this might be 5. So is 20 times 5 centimeters equals 100 centimeters squared. And the next sort of shape is where we have to remember a formula. So we'll do a triangle, and this has an angle in there of 90 degrees, and so this one is called a right angled triangle. Now, a right angled triangle, how to work out the area of a right angled triangle? It's the area equals half BH, and the B stands for base and the H stands for height. Now this must be the vertical height, not slopey lines. So if this base, let's do a different color, if this base was 10 centimeters and that was 8 centimeters, then the area of this triangle equals a half times 10 times 8, which equals 40 centimeters squared. It's because the reason why we've got half is because if I continue that and make a rectangle, then the size of the rectangle will be 8 times 10, which is 80 centimeters squared. So the triangle is exactly half of the rectangle. That's why we use the half at the beginning. Now, if you have a triangle like this, whoops, we're still going to use the area equals half base height. So call that 8. But we must now know the vertical height of this triangle, which call it 6 centimeters. Sometimes they'll put a unit on there or something. Ignore that, it's just to throw you off track. So this one is going to be half times the base, which is 8, times the height, which is 6. And it doesn't matter which way round you do this. 6 8s are 48. Half of 48 is 24 centimeters squared. Right, so area, this shape, a parallelogram. A parallelogram of 12 centimeters. And again, we must have the vertical height, which is 6 centimeters, not the sloping kind. So it's 6 times 12, which equals 72 centimeters squared. Okay, the next one is a trapezium. Now, this is parallel to this. These sloping sides can be any which way you like. It could be like that, or it could be like that, an upside down thing, yeah. Anyway, they don't have to be the same. Now, in order to find the area of this, we must have, again, the vertical height. So I'm going to call that 10 to make life easier. This is A and this is B. Now, because we've got one long side and one long line here and one short line, short at the top, long at the bottom, we've got to find the average of these two. So the area of a trapezium is going to be A plus B divided by 2 times the height. And the A plus B finds the average by dividing them both by 2. So if we have some numbers on here, we said that's 10, so we call that 15 and I don't know, 21 centimeters. So we've got 15 plus 21 divided by 2 times 10. 15 and 21 is 36 divided by 2 times 10, which is 18 times 10, which equals 180 centimeters squared. This might not be called A and B, it could be X and Y or P and Q, but yeah, it's basically top and bottom added together, divided by 2, multiplied by the height, finds the area of the trapezium. Right, so then we had a pretty tricky question to look at, and we found that there were plenty of ways to do this. So we had a line of symmetry in the middle, and then we had that, and then we had that, and that. And we had some measurements on here, so this was 2 centimeters, and this is parallel to this, and this one was parallel to this one. And we said that the whole thing was 10 centimeters wide, and the whole thing was 8 centimeters. I know it doesn't look like it, 8 centimeters high, and we had to find this bit in here, yeah? Or did we? Or was it the other bit we had to find? Oh no, we had to find the other bit, yeah. But it doesn't matter, so we'll do the blue bit, yeah. We had to find the total area of the blue. Bear with me whilst I colour this in. Right, so we need to find the area of the blue part. And the way to do this, well, there were several ways, but the way to do this is the left is the same as the right. So we just need to work out this bit and this bit maybe, and double it. Now, so did we have that was 2 centimeters as well? Yeah, so this triangle here, I should call A, looks like that. And it's 2 and 5 because it's half of that. So this is half base height, which equals a half times 5 times 2. 2 5s are 10, half of 10 equals 5 centimeters squared. So if this is 5, then this one will be 5 over there. So we've got 10 so far. Now this one, what I did was, well, it's just one way of doing this, yeah? I divided that up into a large rectangle, which is like this, with 2 on there and 10 on there. So that's just simply 2 times 10, which equals 20 centimeters squared. And then we have one of these triangles. Now we didn't know the top of that, but the way to find the top of there, which is going to be along there, is because this is parallel to this line, it means the height of that triangle is the same as the height of that triangle, which is 2. So therefore the height of that triangle is 2. So we've got a triangle there with 2, and the width of the triangle is half of 10, so that's 5. So we've got half times base, 5 times height, 2, which equals a 5 again. So it's exactly the same as that one at the top. So that becomes 5, that becomes 5, and this one was 20. So altogether, we've got 20 plus 5, 5, 5, 5, that's another 20, equals 40 centimeters squared. A tricky old one, that one. It took quite a lot to do. Then we looked at, let's have a look at it. It was a triangle. It was a triangle. So we looked at this, this, and that, and that's something like that. So these two lines here, the sloping lines, are not parallel to each other. So that was 6 and 3 and 8 and 3. And we had to find this area there. Now, this is one triangle inside another. So if we find the area of the large triangle and subtract the area of the small triangle, we'll find out what the area of this bit is up there. So the large triangle is half base height, which equals half times 11 times 9, which is half of 99 is 49.5. And the small triangle, half base height, which is a half times 8 times 3. 3 it's a 24, that's 12. And if we do 49.5 subtract 12, we get 0.5737, probably centimeters squared, 37.5 centimeters squared. Okay, so the next shape we looked at was the circle. The circle. So let's have a look at the circle. So the circle all the way around the outside on a circle is called the circumference. And the line from the middle to the outside is called the radius. And the line that goes through the middle all the way is called the diameter. And to work out the circumference of a circle, you need to be given either the radius or the diameter. The diameter is twice as big as the radius. So here's the formula for the circumference of a circle, is pi d. Now pi is a button on your calculator, and when at all possible you must use that unless they specifically say something else. So if we say this has a radius of, I don't know, 4 centimeters, to use the d we have to double this. So c will equal pi times 8. I'll just do that on the calculator. So shift pi times 8 equals, now obviously 8 times pi equals 8 pi, and this is an answer in terms of pi. If we multiply these two numbers out, we get an alternative answer of 25.13 centimeters, and this is to 2 decimal places. So you might be asked to give your answer in terms of pi or as decimal places. So that's when you're given the radius. You can be given the diameter as well, which is even easier because you just use the number straight away without bothering to double it. So that's how to find the circumference. Now, the next bit we did, we looked at the circumference of perhaps a semicircle. Not very good semicircle. Now this is now called the perimeter, because we've got a straight line as well. So if this length here is 10 centimeters, what we do is we write down the formula for working out the circumference of a complete circle, and we've got to divide it by 2 because we've only got half a circle. So that bit there will find this curved bit at the top. Now don't forget we need to add on 10 because we're finding all the way around this shape. So the diameter is this line here, 10. So it's pi times 10 divided by 2 plus 10. So 10 divided by 2, we can simplify that a bit to 5. So that will equal 5 pi plus 10. So that is in terms of pi. Now if we wanted to do the decimal, we just go 5 times pi plus 10 is, the decimal places, 25.71. and it's a length measure, so it's centimeters, so we need centimeters. So we've got terms of pi or as a decimal to two decimal places, two possible answers. Read the question carefully to find out what they want you to do. Now, areas. Right, so let's have a circle with an area. So we're going to find out the area now of this, and again we've got the radius and the diameter and the circumference. So the area is all that bit in the middle, and there's a formula for this, is pi r for radius squared. Yeah. Now, if we're given the diameter, we would have to half that number. So let's say the diameter of this is 12 centimeters. So we need to half that to get it into there as a radius. So that will be 6, and it's squared. Now, 6 sixes are 36, so that would be 36 pi centimeters squared, as in terms of pi. So as a decimal, we would just go pi times 36, and that would be 113.10 to two decimal places. Awkward, look, 10. Never normally put that when you've got a decimal, but you need to put the 0 in there to explain to or demonstrate to whoever's marking this that you have understood the two decimal places. So that's how to find the area of a circle. Now, of course, we can do this, the area of a semicircle. The area of a semicircle. And we're going to give this as, I don't know, 20 centimeters. So the area is equal to pi r squared divided by 2 this time. R, the radius, is 10. Yeah. So 10 squared, so it's going to be pi times 100 divided by 2, which is equal to 50 pi centimeters squared. Now, if we do pi times 50, we can do it as a decimal again, 157.08 centimeters squared to two decimal places. Right, so that's, and if we had a quarter of a circle, we'd just do pi r squared divided by 4 this time. Right, okay, move on, onwards and upwards. Now, we're going to look at a sector. So I'm going to do it nice and big so we can all see what's going on, yeah? So here's a circle, there's the middle. If we have a straight line there and, or I don't know, a straight line there, yeah? This is a radius. And this bit here is called a sector. Now, if we have, and this is also a radius over here, yes, because it's exactly the same. Now let's call this 12 centimeters. So to find the area of a sector, right, we know the area of a whole circle is pi r squared. And it's not times a half or a quarter, we don't know. So we need something else in there. We need this angle to work out a fractional part of the whole area. So this would be 60 out of 360, because 360, is all the way around. So it's only a bit. So let's do this, is pi, radius is 12, 12 squared is 144 times 60 over 360. Now, I recommend that you don't do the divide bit first. just work your way along on your calculator and go pi times 144 times 60 divided by 360 equals. So pi times 144 times 60 divided by 360 equals. Now that equals on your calculator just comes up as 24 pi, which is good, and this is centimeters squared, and 24 pi is actually 75 point, what should we call this, 40 centimeters squared. So that's how to work out the area of a sector. It's the area of the sector is determined by the angle that the sector makes with the middle, with the center, because then that number 60 will change. All the rest, pi r squared times something over 360, it's just the something is this number here. Now, another little bit that we've got added onto this is this bit here. This bit here. Now, we know that all the way around a circle is called a perimeter. This is called an arc. Now, if we want to find out the length of that arc, we go back to the circumference equals pi d. That will find all the way around, and then again we just multiply that by 60 over 360, and the diameter is double this, which is 24. So this will equal, I'm going to come over here now, pi times 24 times 60 divided by 360. So pi times 24 times 60 divided by 360 equals 4 pi centimeters. Everything's in centimeters, yeah? Now, 4 times pi is the same as 12.57 centimeters to 2 decimal places. Okay, that is how to find out an arc and how to find out a sector. One more little horrible bit to this is nice and big, yeah? So from the middle, we're going to go 60 again, because we like 60, and this time we could just call this 8 centimeters. Now, we know that's a sector, and we know that bit's the arc. Now, if I draw a line between there and there, this bit here is called a segment. And it will be obvious what you need to do, whether it's a sector or a segment, because this will be the drawing on the exam paper. So what we're going to do is find the area of the segment. Now, so we need to find the area of the sector, as we did just now. Then we need to find out the area of the triangle and take one away from the other. So first of all, we do the sector, which is the area equals pi r squared times 60 over 360. This is pi times radius 8 squared, which is 64, times 60 divided by 360. So pi times 64 times 60 divided by 360 is 32 over 3 pi. That's a bit awkward, isn't it? So this would probably be the one where they'd ask you to do it to decimal places, and we will do that. 33.51 centimeters squared. So that is the area of the sector. Now we need to find the area of the triangle. Now, the area of the triangle here is not found by half base height. It's not that. It's similar, but it's not. The reason why is because this is a bit of a weird triangle. No matter which way you place it, if you imagine this is the base, you can't find the height. And if this is the base, you can't find the height. You can only find the slopey sides of the triangle. You have no height. So we have to multiply this by something else. So it's similar to this. Now the area of a triangle is called the sine rule. We'll use this. I've pronounced it sine but spelt it sin. It's the sine rule for area. And it is the area equals half. And now instead of using base height, we are going to use A and B for the radius. Half AB. Now we need to multiply this by something else to take into account this angle here. Sine C. So it's ABC. Yeah. And that will be half times 8 times 8 times sine the angle C, which is this one, which is 60. Now, what does all that come out to? So 0.5 times 8 times 8 times sine, you've got it on the calculator, put in number 60, and that will be 27.71 centimeters squared, just slightly smaller than the sector up here. So to find the segment, we need to subtract one from the other. So the segment is over here, so it's 33.51 minus 27.71, which is 0, 8, 5, yeah, 5.8 centimeters squared is the segment area. So that is a lovely grade 6-ish, grade 6, to finish up that lesson on perimeters and areas. Okay.